So the robot starts in the home position, it moves up to the ready position, and then it will do a small sweep, and then it will find a strawberry using OpenCV. And now this algorithm is set to center it in an XY position in the RGB frame. And then once it's centered, it will use its point mapping, the depth cloud, which is given to us from this camera. And then it actually calculates the depth it needs to move in. So that was a miss. So if it doesn't miss, it'll just come back and go through its detection algorithm where it sweeps, finds one, and it'll just do it again. So right there, I'd consider that a pretty good shot. And then it would close, pull back, and drop it. Perfect. All right, so now to go over the different components of our arm, we'll start at the end effector, which is the tool or hand, and that has attached with it the Intel RealSense camera. You can see the mini lenses. You can actually see the laser. Whoa, check that out. You can see the laser shooting in on the camera, and that's what's giving you depth mapping. So that little pink magenta laser you can see right now in the screen is that. This camera right here, and this camera give you stereoscopic imaging, and then this lens right over here on the far left is just the RGB. And then the servos that control the gripper is a Dynamixel, so that's an off-the-shelf part. Here's another one, the XL320 Dynamixel. And then this is the XL420 Dynamixel. And these servos just come pre-built with a microcontroller inside, and we're communicating that with those over UART. And then here's another one. So together, this motor right here would give you, I guess, yaw on the arm, forearm. This one would give you this motion on the wrist, and then the wrist can actually turn this way. And then the primary joints are driven by stepper motors, not servos. And these ones we custom designed this chip, this PCB, which has on it the STM32. That would be this black chip right here. Underneath this heatsink, which gets super hot, is the stepper driver, IC driver. Underneath that board is a magnetic encoder. And then here is the stepper wires come out to this. And then this is the data bus and voltage bus. And there's one on this joint that gives you this axis. And then there's one that drives this axis, and that would be this stepper motor. And it's driven with this belt. And then underneath is your shoulder joint. And then all of this data trunk is connected just by this one cable. And that comes into the Pi shield. And the Pi shield has this transceiver, which handles the UART half duplex. And that interfaces with the Raspberry Pi, which is underneath the Pi 4. And that's how it communicates. And then these are two buck converters that convert this 24 volt power supply that you would see on your laptop. It converts it to our three primary voltages we use, which is an adjustable, I call it 10 volts, but it's actually 8.4 volts. And then we have 5 volts, which is what the Pi uses, and all of the MCU, the STM32s. And then on the screen, we're able to visualize everything the camera sees. So this would be an example of what the point map cloud sees. It gives you depth, and here we're just using color filters, and the color represents different depths. So you can see the blue strawberry right there bouncing around. That blue represents a depth field, so it distinguishes it from anything beyond it. Now as you get closer and farther away, it gets to different colors. So together, the RGB camera lens detects the camera with OpenCV, And then the depth cloud gives you its depth.